In this class, we're going to consider how you solve linear equations which have got fractions in them. So generally when you're starting equations, you learn the basic kind of forms, the basic rules. You learn how to deal with equations that have got brackets in them, or maybe slightly awkward numbers, maybe more negative numbers. And then you move up to the next level, which I would consider to be equations that have got fractions in them, which are more difficult than the previous two, but they're still following along the general principle of solving an equation. You're still doing the same thing, trying to achieve the same thing, figuring out what the value of the x or whatever the letter of choice is that satisfies the equation. You can see just by looking at these, they're at different levels. Clearly this one's more complicated than the other guys, but the process we're going to take to solve these is fairly similar in the sense that basically you just want to get rid of the fraction as quickly as possible. In the same way that when you've got equations that have got brackets in them, like parentheses, you want to get rid of those as quickly as possible. Then you've just got a normal linear equation, and you just go through all the steps to solve it. That's what we want here. We want to get rid of these fractions so that we can just have a nice friendly equation, and then we can just solve it. So that's going to be our goal. How we achieve that though will depend on a few things. It will depend primarily on whether you've got one fraction or whether you've got two fractions. We might need to bring in some ideas about combining fractions. We might even need to bring in sort of algebraic fractions, because that's what these guys essentially are. These guys and that guy and these guys. Or maybe not, it just depends really on the question. So that's why, like all equations, the more variety of types you see, the more examples that you can work that look different from each other, then the more skill you're going to have, the more experience you're going to have, and the better you can then handle them. So starting with this guy here, this one's not too bad because we're quite close to like the end point basically of solving an equation. So remember that the last line of that normal linear equation would be usually something like number x equals, say, number, something like that. And then we just divide as our final step. So we divide both sides by 2 and we get x equals 6 in that case. You could do that here. You could just say, right, well, I've got number, happens to be a fraction, times x equals 5. I could just go ahead and divide both sides and get the answer, dividing both sides by 3 over 4. That would work. So you would end up with x equals 5 divided by 3 over 4. We're then dividing by a fraction, which is slightly awkward, but the rule for that says you just turn it into a multiply and then flip the fraction. So 5 times 4 over 3 is 20 over 3. So you're getting a final answer there of 20 over 3. And that's cool, that's fine, that does work. That's not the approach we generally take. Well, for these ones we could, for that one we could, but as they get more complicated, that method's going to break down. And generally we want to avoid dividing by fractions if we can, because it does just make things a bit more difficult. So we'll kind of park that idea. That is an option, maybe just not always the best option. Instead, what we're going to do is get rid of the fraction. So a fraction means divide. So this is saying divide by 4. We can neutralize that. We can get rid of that by multiplying both sides of the equation by 4. So we're just multiplying through the equation by 4 to get rid of the times in by 4. It's very tempting to, well, let me actually just show you what's going to happen. These guys are going to cancel because this 3 is being divided by 4 and being times by 4. It's very tempting, like I was going to say, to rewrite this as 12 over 4, and that's okay. You can do that, but you don't need really to write in that line of working, because the whole point of timesing by 4 is to get rid of the 4. So effectively these guys just cancel. We've got rid of that 4 on the denominator, as long as we remember to multiply the other side by 4 as well. So we're going to end up with just 3x equals 20, 5 times 4. So that's basically what we do. The other common mistake is to multiply this by 4 to get 3x, but to forget to multiply that by 4. So remember, an equation represents equal quantities, so you've got to do the same things to both sides to keep it sort of balanced. So we would get 3x equals 20, dividing both sides by 3, and we get 20 over 3 as our solution. So we get the same solution as we got over here. It doesn't matter what method you use to solve equations. There's always going to be a little bit of variation in how you go about them. You should get the same answer though if you do them correctly, regardless of the method you use. So that one's kind of an entry level question. This one, slightly different format, but also kind of entry level. You've only got one fraction to deal with. So we're just going to take the same approach. We're going to say, right, we want to get rid of that dividing by 2, which is what that is saying. Just a way of writing dividing by 2. So we're going to times both sides by 2. That will just cause these guys to cancel. We're going to end up with x plus 1 over there on that side. 7 times 2 is 14, so we get that. And then just moving the 1 over to solve like a normal linear equation, we will just get 14 minus 1, so 13. So not too bad there for that one either. We were able to get rid of the fraction after one line of working and then just carry on like a normal linear equation, just like we did up there. As we move into these ones, they're going to be a little more complicated because primarily we've got a second fraction to deal with. There's different ways you can go about this. There's quite a variety actually of methods to solve these. I would say if you've got multiple fractions, try and make a common denominator. If you make a common denominator, you can then take the same approach as we've done here, just multiply through the equation by that common denominator and then get rid of all your fractions in one go. You could do that at this point. You could multiply by a number which has got both of these as a divisor, for example 8 or 16 or 32. That would get rid of both of them, but then the numeracy becomes a little more complicated. So what I'm going to recommend is that we turn this fraction here into something over 8. So we're just going to leave the first fraction, so x over 8 on that side of the equation. This guy we want to turn into an equivalent fraction as something over 8. So to do that, we're just going to times top and bottom by 2. So that's not really the same as we did over here. This is just rewriting the fraction 3 over 4 in an equivalent form, which would be 6 over 8. The beauty of doing that is now we've got the same denominator on both of our fractions. If we just multiply both sides of the equation now by 8, so that idea of balancing your equation, doing the same thing to both sides, then these guys cancel, and that actually just takes us straight to the final answer because we're just left with x equals 6. So one fraction, get rid of the fraction straight away just by multiplying by the denominator. Two fractions, one of the approaches, although not the only approach, is to take an equivalent fraction to make the common denominator and then multiply through by that and then do whatever you've got to do at the end. Okay, let's scope out this guy. So it looks a bit more complicated, is slightly more complicated, but a fairly similar approach really. We've got two fractions, they're both algebraic. They don't have a common denominator at the moment. We can make them have a common denominator by considering them as algebraic fractions, which they are. If you're not familiar with this, you might just want to follow along and then check out how to combine algebraic fractions, how to add them later on by checking out that class. Or it might just make sense to you, or maybe you're comfortable with this already. But basically to combine these, we're going to multiply the denominators to make a common denominator, and then we cross multiply to change the numerators. So in effect, we're multiplying this fraction top and bottom by 3 and multiplying this one top and bottom by 2. So we're not changing the fractions, we're just writing them in a different form, just in the same way we rewrote this one in a different form here. So 3 times x plus 1 would give you 3x plus 3, or you could write that as a 3 bracket x plus 1. I've just gone ahead and multiplied out the bracket, either way is fine. 2 times 3 is 6, so it gives us that. So effectively I've just multiplied top and bottom there by 3. Keep the plus in the middle. For the other one, we're multiplying top and bottom by 2, or cross multiplying the 2 up there to give you 2x minus 2. 2 times 3 again to give you 6, and still equal to 1. So the beauty of doing that is that we now can merge these two together to make one fraction. So all of this will be the top line. So 3x plus 3 plus 2x minus 2, all of that over 6 equals 1. And the good thing about that is that we can now multiply both sides of our equation by 6 to get rid of the fraction. So times 6 over here, times 6 over here. It's going to make a little space and move my working up to this point. So a little bit more work with this one to get it to a point where we're able to get rid of the fraction, but that's quite a typical scenario actually with these questions. So look out for making this the kind of point you want to get to. Start with guys that look like this, work your way through more difficulty to get to this sort of point. So at this point we're just multiplying by 6, so these guys are going to cancel on that side. I'm going to go ahead and combine the terms as well, so 3x plus 2x to give me 5x, and then you've got 3 minus 2 to give you plus 1. Other side of the equation, remember to multiply it by 6 as well to get a 6 over there. Then it's just a normal, friendly, easy linear equation. So we get 5x equals 5 by moving that 1 to the other side, and then just dividing by 5 to get x equals 1 is the final answer. So you can see there's just more work involved in that one. We're bringing in a bit of algebraic fractions, keeping track of our algebraic terms, and then it's not until we're a few lines of working in that we can actually start to think about getting rid of the fraction like we did over here, whereas like this kind of entry-level question, we just went straight in with getting rid of the fraction. So by the time you get to that level, which is where you should be aiming to get to, there is quite a lot to keep track of. You might need to revise, or maybe even for the first time see algebraic fractions to be comfortable with this. But that's a common presentation of this type of question. Remember as well the idea of equivalent fractions, so just multiplying it, say top and bottom, to make it the same denominator as another fraction type. So just take your time and make sure that all of that makes sense to you. And once it does, then as always, scope out a few practice questions on this topic.